Okay, so yesterday we have done the rotorcraft and the fixed wing operations and aerodynamics topics. Okay,
Okay.
in that which we learned about how the fixed wing flies. Basically, fixed
Hmm.
wing is nothing but same to the aeroplane leg, whereas the rotorcraft flies based on the principles of Newton's third law. Okay, that is every action has an equal and opposite reaction. So as the propeller starts moving, the drone, as it's able to generate enough thrust, it will take off from the ground and flies in the air. Okay, it will keep on flying till it has power. The battery, whether the battery is providing. Mostly the rotorcrafts are being powered by the battery. So as of
Right.
now, there are very hardly I would say not even 1% of drones available which are powered by any other source as of now in
Okay.
rotorcraft. Okay, mostly rotorcraft are powered by the batteries. So now the combination of the fixed wing and the rotorcraft. So when we are talking about fixed wing and rotorcraft, both options, we saw the pros and cons. So can you tell me what is the pros and the cons of the fixed wing? What are the advantage of the fixed wing? Like where do
It
we
Fixed
can
wing
travel long
can
and greater
travel
speed.
long, yeah,
Yes,
longer at greater speed.
it can fly very high up in the sky
I,
as
yeah,
well as very long and for
yeah.
a longer duration also.
Longer
Fast
duration.
paced. Yeah.
Okay,
Yes,
so it can cover up longer area or bigger area as well as fly higher also as well as for a longer duration.
longer
Yeah.
duration.
Most important, another part is that it is aerodynamically stable
Stable.
because the fixed wing is designed aerodynamically.
Yeah.
And then if you see, it can carry much power weightage also. I mean, with
Higher payload.
higher
Higher payload.
payloads and all the things. That is the advantage of the fixed.
Yeah.
But what is the disadvantage of the fixed wing?
It needs a long
You need
runway
a
to
big
take off.
Yeah, it needs
runway.
since
You
take
can't.
off. Either it can be hand. The smaller fixed wing can be
Catapulted or
hand thrown, or the bigger fixed wing needs a runway.
runway.
Yeah.
So that is a disadvantage we could think about.
Exactly.
And
It also cannot take off vertically and land
Yeah.
vertically.
yeah, so what is the advantage of the rotorcraft? Advantage of rotorcraft is that one is it can hover at one particular location.
Location.
Yeah.
It can vertically take off and land,
Take off
so it
and land.
really
Yeah.
doesn't require a runway.
Hmm.
But it is powered by the electric batteries,
Battery.
lithium-ion or lithium polymer batteries,
Yeah.
which can
So less
provide a very less endurance time, like it
Yeah.
could 20 minutes,
Less
30
travel time.
minutes, max to max 1 hour or 2 hours, not more than
Yeah.
that. Okay, because as you keep on adding the battery, the weight of the drone also will increase.
Goes up.
Increase. Yes.
Okay, so which will compromise on the flight time also.
Flight.
So this
Yeah.
is the disadvantage
Stability and all.
of the rotorcraft. Okay, the
Yeah.
advantage is hovering, advantage is vertical takeoff and landing. Okay,
Land.
these are the advantages. Okay, so the whatever the advantages of fixed wing and the advantages of rotorcraft are combined and created a new category of drones or unmanned aircraft system. That is what we called as hybrid.
Hybrid.
Okay,
Hybrid.
hybrid or VTOL, vertical takeoff, like people call it as also VTOL. Okay, so hybrid basically it's like the same like your fixed wing. So it needs it can fly like an aeroplane, whereas when it is taking off and landing, it can take off and land as a rotorcraft. Okay, so combination of both, it can also hover as well as it can fly horizontally in the sky also. Okay, so let's see the principles of aerodynamics are applicable to hybrid drones also. So types of hybrid drones, parts and application of hybrid UAVs.
Okay.
Okay, so principles of aerodynamics remain same here because it's similar to like a fixed wing. So the four forces acting on a drone is like lift, weight, thrust and drag. Airflow changes and pressure distribution over the airfoil. So when it is behaving or when it is transition as a fixed wing, it will fly like a fixed wing aeroplane or fixed wing unmanned aircraft system. When it is transitioned as a rotorcraft, it will behave like a drone or it will behave like a unmanned rotorcraft, unmanned air vehicle, and probably the rotorcraft activity is only required for takeoff and landing. Okay, once it takeoffs, it changes into the fixed wing structure and start behaving like a fixed wing and perform its activity. Once it's complete the activity, comes back to the base, it will again transition back to the rotorcraft and it will land. So here you are actually saving the space or the area so that you don't require a big runways or anything like that. The advantage of the hybrids are basically the place where you do not or you do not have option or you cannot create some long runways like area like Ladakh, area like Assam, area like
Height area, like,
Kerala, where the terrains are very big. Okay, you do not have a flat surface lands. Where in those locations normally the hybrid drones are very very useful.
effective.
So again the same airfoil concept comes here because we are using the fixed wing over here. Okay, so leading edge, trailing edge, chord line, camber line. Camber line is nothing but is additional line which is actually equidistant from the surface, from the upper surface as well as lower surface. See, the chord line is a straight line
Straight.
from leading edge to trailing edge, whereas camber line is a line equidistance from the upper surface and the below surface, any given point in time. Okay, if you see here, the distance from the upper surface and the lower surface would be same. So it will be a curved. Camber line will be always a curved line, whereas chord line is a straight line leading from leading edge to trailing edge. Camber line is a curved structure. Okay, joining the leading edge and the trailing. But what is the definition? It says it is the equidistance from upper surface and the lower surface. Okay?
Lower side.
Line joining the leading and trailing edge on the airfoil, equidistant from the upper and the lower surface.
Lower surface.
So what are the force acting on the hybrid? Lift is the force that
Lift,
goes
weight,
in the
thrust.
air. Wing creates most of the lift used by the airplane. Weight is the force caused by the gravity. So weight है, वजन है. So it will definitely, the gravity will affect on the aircraft. Thrust is the force that moves aircraft in the direction of the motion. It is created with a propeller or a jet engine or a rocket. Okay. So air is pulled in and pushed out in opposite direction. One example,
Opposite direction.
household fan. Drag is the force that acts opposite to the direction of the motion.
Of course.
Okay, so drag will be always opposite of the motion. जैसे हम लोग कार ड्राइव करते हैं तो हमको फील होता है, राइट? इसलिए हमारे सामने विंडशील्ड होता है, राइट? So that
Exactly.
the air doesn't push us back. Like when we are riding on a bike, we feel that air, right?
Exactly.
Since bikes doesn't drive or doesn't ride at very fast speed, but in a car we definitely require a windshield in front of you, or it will be very, over the period of time it will become very difficult to drive. Okay, so drag is the force that acts opposite to the direction of motion. It tends to slow an object. Drag is caused by the friction and difference in air pressure. Okay, example is like if you put a hand outside when you are driving, you just put a hand outside, you will feel the air pressure, right? You will feel the pressure. But you just tilt little bit, you will see your hand will start going up. Okay, it will go up. But if you tilt more, you make it horizontal completely.
Sideways.
So what will happen? It will not go up, but it will go back. This is
Sideways.
back.
It goes back.
Right? It goes back. You pull back. So parts of the hybrid drones, you can see here, it is similar to your fixed wing. You can see here there is a wing which has the airline structures. Then you have a center part which is a fuselage, okay, which will have the your battery or whatever the mechanism you are used for powering it. And then you will have a payload like camera, gimbal and all that things at the base. You can see there is a one motor is there, center motor is there, which is called as a pusher motor. Okay.
Pusher.
So this is basically, since it is at the tail end, it is called pusher motor. If it would have been the nose end, it would have puller motor.
Puller.
Okay. And then you have four motors connected at the four corners. Okay, these are nothing but these are lifting motors. Okay, so these are only used when your drone or the hybrid drone is at the ground and it needs to take off. Okay, that point in time only the lifting motors comes into picture. Once it's transitioned to the fixed wing, automatically these four motors will stop rotating and the pusher motor would have already started rotating it. So it will transition as it takes off, it transitions and start moving forward directions. Okay, by pusher motor. That point in time when the pusher motor is in act, that time the lifting motors would stop. That's how you save the precious battery time and you are able to cover a larger area in that area. Okay. Then you have vertical stabilizer, horizontal stabilizer, since it has to behave like a like a fixed wing. So
Plane. Yeah, that's
gives
plane.
these control surfaces or control structures to control the direction and altitude or lift for that particular flight. Okay, there are different configurations. Like if you see here, there were total five motors. There are hybrid drones which are designed with only four motors also. Like you see here, initially it will take as a vertical takeoff, so motors are upward direction. Okay, so as it takes off, the motor will start changing its orientation. So that is called transition maneuver. So it is moving from a rotorcraft, it will become like a fixed wing. Okay, so the motors will become horizontal and they will start pushing forward. So maybe at that point in time, the behind motors will stop working. Only two motors will be functioning. So only instead of four motors, you are only utilizing two motors per flight. So it will continue on the two motors.
Yeah.
And then again, when it comes for a landing position, again the motors which are horizontal, they will start transition to vertical position, and then slowly it will land. That is vertical landing. So here instead of five motors, we have come to only four motors. So we have reduced motor, and when in a flight, normal flight, you are only utilizing two motors instead of four motors for rotorcraft. अगर रोटरक्राफ्ट कॉन्फ़िगरेशन में अगर ये ड्रोन फ्लाई करना होता तो चारों मोटर को रन करना पड़ता है, राइट? So when it is transition to a horizontal flight mode, it will only utilize two motors, front two motors. Okay, so that's how you are saving precious battery time, and you are able to cover large area, and you are able to complete your project. Okay, the next combination is like this. Okay, vertical wing.
Yeah.
Okay, this is called vertical wing structure. Here you can see there are only two motors. Okay, so here what happens, the aircraft vertically takes off, and then by changing the angle of the ailerons, it will automatically change the orientation. It will become flat and then start moving. So only two motors are continuously in use. So this also has a very good advantage. This is one of the best hybrid drone what I have seen. And similar drone we are actually designing for one of the company in Rajasthan. So we have currently completed the design phase. So more or less it was similar to this type of design. Probably by end of this year we should able to get it certified in India. Okay. So basically this we are designing for surveillance in area of Rajasthan and border area and all that thing for surveillance. Okay.
So this is the government project, right?
Yeah. I mean, we have tied up with one of the government, state government over there as of now, and probably we'll propose it once it is certified, and also probably we'll approach.
So you are having the patent rights or the company?
No, the company will.
The company
I'm only the consultant.
Okay.
Yes, sir.
So I think you forgot to take attendance.
No, I have taken that.
You taken? Okay.
Yeah, I have.
ठीक है.
माझे नाही घेतले सर.
No, I have taken.
घेतले का?
I have taken.
Okay.
Starting में सब मिल गया.
क्वेश्चन चल रहा था तभी आपका वीडियो ऑलरेडी ऑन था, तो आई हैव टेकन दैट वन.
Okay.
Okay.
Okay. So you can
You say all this.
So basically, if you see, hybrid drones are already 5 motors. Then you saw a drone with 4 motors where it transitions from vertical to horizontal. And then we have a hybrid drone which has only 2 motors where the entire structure transition from vertical takeoff to level flight flying. Okay, so these are different types of hybrid drones available. Okay, so each has its own advantages and again disadvantages also. Okay, like यहाँ पे देखो ये structure काफी बड़ा हो जाता है. Like I would say very efficient design is this one, the Vintra one. Okay, the orange color. Okay, this is a very efficient design, and it's a very good drone. It comes in a small box because ये सारा fold हो जाता है. Only the wings जो है उतने ही बड़े रह जाते हैं, बस rest everything can be detached. यानी कि आपका ये जो tail section है ये सारा चीज आपका detached हो जाता है. You can put it in a bag also. I mean box, small box and come. And then this has, like, this is a version 1. Currently the company has come up with version 2 which has the payload of like lidar and all that things available. Yeah. So this drone is being used in European countries where
Okay. I was going to ask you, is it an Indian company, Vintra? No.
Europe.
Okay.
Vintra. Okay, so application of hybrid VTOLs are used in operation where the terrain is difficult, as we discussed. Terrain is difficult to land a fixed wing airplane, but endurance needed to be more than multi-rotor. Okay, so whatever the pros, I would say, are the options of the fixed wing and the rotorcraft are being considered in hybrid VTOL. Okay, it is used in large area mapping. As I said, it is used in a large area mapping. It is used to transport heavy payloads over large distance with hilly terrains. Like Qatar जैसे location में आपको cargo delivery करना है and all that things where you cannot build the long runways and all the things. So these hybrid VTOLs are very effective in these areas to do it. It is used in search and rescue areas, rescue operations, and also as well as for cargo deliveries also. Okay. So that's all about the hybrid drones. If you have any questions, we can take up, or we can take up the next topic. So with that, we complete yesterday's all the 6 modules. So last module hybrid, I didn't take it yesterday though I had time. This was not big module, but I wanted you to focus more on the fixed wing and the rotorcraft, so that in a fresh mind we can discuss about the hybrid, so that we'll able to we started with like comparing the fixed wing and the rotorcraft. We saw the pros and cons of both options, and whatever the best options are available in fixed wing and the rotorcraft are utilized in a hybrid drones. Okay, or hybrid or VTOL drones. Okay, so
So yes.